All right, so we're jumping into rotations about the origin. So we've previously done linear transformations, and this is sort of from our text, but let's go into the investigation first so we can consider it. So if you've already done this, you don't need to, you could jump ahead in the video to when I go back up. But in the investigation, it asks us to consider the following transformations and consider a transformation matrix A. So what we need to do is we need to, for this investigation, we need to consider a point. And so the idea being that if we pick any point, now I'm just going to go over here. From our unit circle, we've got, this will have a coordinate x, y. So we sort of already know this bit. Now, if we have a clockwise rotation about the origin through pi on 2, we know that's a 90-degree turn here. So that is, if I come out, this here would be 90 degrees. Now, what you've got to remember here is that this angle here would be the same as this angle here because of the 90 degrees section of it. So if we consider this triangle, now I'm going to do this and then I'm going to remove it just because what we would find here is this little bit here would be equal to the same distance as this little bit here. So what we see is this y value here would give us our x coordinate. It will give us that distance, but it'll be a negative x value. So if we come back to our pen, what we've got here is the x is going to be negative what our y value is there. Okay, and then if you think about this length along here is going to be what our x coordinate is here. It's actually what our y coordinate is going to be here. So we're going to end up with this new coordinate means whatever x value we had there becomes the y value here. And so we're looking at, if we just consider this transformation, I'm just going to go back to our, so we've got x dash y equals xy, and we get a, b, c, d. And here we've got our input values, x and y. And what we see here is you'll notice that our x value here becomes negative y. So we've got x dash equals negative y, and then y dash equals positive x. Okay, so that means here that if we think about this transformation matrix, this A matrix here is going to be, well, because because there's no x value in this top equation, A has to be 0, and then B has to be negative 1. So we get 0 and negative 1. And then this next one, we've got a positive x value, so positive 1 and then 0. Now, the determinant of this, you've got to remember the determinant of A is going to be AD minus BC, which is going to equal 0 times 0 minus b is negative 1 times 1. We get a determinant of positive 1. Now, that determinant becomes really vital later. So that's our first one done here. This next one is if we rotate clockwise about the origin. So if we consider this one here, it means if we've got this same point here, okay, if we go clockwise, we're going to be down here. And what we should see here is the x and y coordinate here. We're going to be looking at, well, this is the x coordinate here is going to be y, because whatever height this is, the x value is positive, but it's the same distance. And then the y coordinate is now negative x, because this distance here along here is positive, but it's a negative here, but it's the same magnitude. So this is interesting because, you know, our transformation here is showing that, well, x dash is going to equal y and y dash is going to equal negative x. So if we think about our transformation matrix here, actually maybe I'll bring the maybe we'll just bring this down so we can talk about it at the same time. Okay, so I'll just paste that there. All right. So you can obviously tell in this one, if we're going to have y, this means that the lowercase b value here, so b will equal +1 and c will equal -1. So the a value here is going to be 0, 0, and we're looking at b was 1 and -1. So it's interesting that it's done a flip, and the determinant would be the same value here, will be +1, because we would have these two multiplied together a -1, but it's the negative value of them. All right, so let's jump on to the next one. Let's just paste. Can we paste that there again? And maybe I'll do it for the end. Paste. Okay, so this next one here says a rotation about O through pi. So that means going 180 degrees. And we should straight off, back from when we practiced a lot with the unit circle, if we have an x and a y coordinate here, they're just going to become -x and -y because it's 180. So that means we're looking at here x dash equals -x, y dash equals -y, which means we're going to need a to be -1 here. So a is going to have to equal -1. B would have to equal 0. I won't bother writing that in. And C would also equal 0. D would equal -1. So then we've got this one. Oh, I should have done it in blue. Whoops. Let's just change. Okay, so back to here. So this means that we're looking at A is going to equal -1, -1, 0, 0. And once again, we're going to have a determinant of 1 because it's going to be -1 times -1, which is positive, minus 0 times 0. Okay, our last one here is a rotation through 0, or we could almost consider this as if we had a 2 pi here. And so that means that we're going to be looking at x and y. When we go through this transformation, they become x and y. So we're looking at, in this particular one, x dash and y dash equals x and equals y, which means our transformation here, our A value, is also going to be a matrix we should know pretty well, but it's going to be 1, 0, 0, 1, which is our identity matrix, and it has a determinant of 1. Now, why have they set us up with this investigation? And the reason being for this particular one is because hopefully we are considering the trigonometric nature of this. And so you should hopefully notice, if we think about going around a circle, our x value here, you know, we have these transformation values, these negative ones and ones, but we're doing pi on 2s and pi, so they've picked nice values for us because it's easy to sort of work these out. And we're thinking, well, what this first one here, when we have a pi on 2, what values give a pi on 2 a 0? We end up with these zeros here, and it's interesting to think, well, pi on 2 has cosine has a 0 there. But when we have a pi on 2 value, we have a sine. When sine equals sine, we have sine pi on 2, we get 1. Now, that must mean that we're looking at, well, that's the opposite up here. We've got this negative, so maybe in our rule we're going to have something a bit different. And when we think about this pi on 2 here, this is like, maybe I should, so this here, if we're thinking about these, cosine pi on 2 equals 0, and sine pi on 2 equals 1. Now this one here, we're rotating the opposite way. We're rotating clockwise. So this would be like cosine negative pi on 2 still equals 0. And sine negative pi on 2 equals -1, which means that you'll notice here that this value here is like -1, whereas up here it was negative. So we're sort of seeing a rule come out here. Now the next one we're thinking about pi. Well, if we have cosine pi it equals -1, and sine pi equals 0. Conveniently, our ones that were 0 before for cosine are now here. So this has pretty much given us our rule, and we'd check it with more specific values. This one here, let's just do cosine 2 pi, and we get this equals 1, and sine 2 pi or 0 equals 0. Now, this conveniently leads us to our rule. This is sort of like an intuition thing. And we got, this rule here, cosine theta gives us the A and D of our transformation matrix. And then we've got this other one is sine, apart from the top right is a negative. So let's look at, let's just look at a basic example for this to practice. So find the transformation matrix A for a clockwise rotation about O through 2 pi on 3. Well, what that's saying there is it's saying, hey, let's just consider, we've got a clockwise. So clockwise is the wrong direction. So we've got to think about that. That's starting here and going the wrong direction. But all we've got to do there is once we work out that, where theta, for this particular one, we're looking at theta is going to be 2 pi on 3. But because it's a clockwise motion, it's going to be negative because that's how we worked when we did trig. So we're considering here this particular angle. If I just draw up a little sketch just so we can talk about it a little bit better. Oh, that wasn't ideal. Let's go one further just to make it a bit nicer, and then I can drag that down one. Okay. And we're looking at 2, oh gosh, don't judge me. There we go. So we've got this circle here. So 2 pi on 3 comes out this way because we're going clockwise. And so that's why I said here, this is our theta. It's moving the opposite way to what we usually do. So that means our A value here is going to be equal to, it's going to be equal to cosine -2 pi on 3. I should make that bigger. Sine -2 pi on 3. And then we're going to have negative sine 2 pi on 3. And then we're going to have cosine 2 pi on 3. Now, in this particular example, you're looking at here, well, cosine 2 pi on 3, when we consider these particular ones, we can use our triangles to work these out. And we should know that this is 1, 2, and root 3. And this angle here, the bigger one, is going to be pi on 3. We always see the symmetry with that particular angle. It's just changed a bit because we're doing 2 pi on 3. So we're looking at negative values of this same triangle, which means that if this angle here is theta, we're looking at cosine 2 pi on 3. Cosine theta here is going to equal, I'll just do it all in the positive and then we'll just change it. So cosine is 1 on 2, and then sine theta here is root 3 on 2. But because these are all in the negative quadrant down here, we're looking at, that means this transformation matrix here. And if you put these in the calculator, you'll get the right value out straight off the bat. It means these cosine ones here, we're looking at -1/2. So -1 on 2, -1 on 2. And then these other two up here, we're looking at root 3 on 2. So this is negative, and then it's going to be negative root 3 on 2. And then this one here is negative root 3 on 2. And so just to clean up the double negative, this is going to equal -1 on 2, negative root 3 on 2, positive root 3 on 2, and then 1 on 2 here. So that's all done there. All right, next little one, we're just going to quickly go through this just because I want to roll through some basic examples and move this. This one here, we're looking at another one. Find the nature of the transformations with the equation, this equation. So you've got to assume we're in rotations about the origin now, but later on we will have a lot of transformations up our sleeve. So I'm just going to change this to a nicer form for us. 3 on 5x minus 4 on 5y, and this one here is 4 on 5x plus 3 on 5y. And so this form makes it a lot easier because we're now looking at our matrix A here. A equals 3 on 5. Let me draw it up as a matrix. We've got 4 on 5 here, negative 4 on 5, and 3 on 5 here. Now, big hint that it's a rotation is these two are the same. These two are the same magnitude but opposite signs. So that's a big hint there. And if you put this matrix straight in, you can get the determinant in your calculator. This determinant is going to equal 1. That's a huge hint that it's a rotation. So then if this is a rotation, we know that these two from our formula up here are going to be cosine theta. So we've got here, hang on, this says cosine theta equals 3 on 5. Sine theta equals, now, this is where you've got to be careful. Sine theta is this bottom left one. The top one is the negative one. So we're looking at sine theta here equals 4 on 5. Okay, so because sine and cosine are both positive, we're looking at, back to the unit circle. If sine and cosine are positive, it means we're up here in quadrant 1 on the unit circle. So if I can draw a nice circle, it would be good first time. There we go. So we're looking at something up here. We're rotating about by something. So realistically, all we need to do now is put cosine, inverse cosine or arc cos in our calculator, and we should get the exact same value for, because we'll do a check, we'll do the exact same operation for sine. We'll use the arc sine as well. And if we put that in, we get, out of this, we should get an angle of 0.927 radians, which is given by the little c at the top. We don't usually use those units though, so I'm going to write just radians there. And because it's positive, it means the transformation a clockwise rotation, anti-clockwise, that call's messed me up, anti-clockwise rotation about the origin.